Hey everybody, I'm fairly certain school is going to get canceled again on Monday because of the impending snowmageddon that's heading our way. So I wanted to put this video together to help you guys get through the 4.5 homework because I really can't afford to keep pushing things back with all of these snow days. So please try to get as much of 4.5 done as you can. Try to rely as much as possible on the dash technique. I swear to you guys, it makes it so much easier. All right, so let's go through this stuff as fast as we can. This is probably going to be a bit of a longer video. I apologize. Okay, um, right. What does this mean? That's probability of B given A. So in this case, it's the probability that a polygraph test indicates that a subject is lying, given that the subject is telling the truth. Okay, so B given A. That's pretty simple. How about determine the description of the complement of when 14 cameras are tested, at least one of them is defective. Aha, remember we talked about this. What is the complement of at least one? None, right? So at least one of them is defective. The complement would be none of them are defective, which means all of them are free of defects, right? So they kind of throw you for a loop, and the none is wrong because it's none of them are free of defects, and that's not what we want. None of the same thing, right? So if at least one of them is defective, the complement is just none of them is defective, and then you got to figure out, okay, well, none of them being defective means all of them are free of defects. Couple plans to have 7 children. Was the probability that there will be at least one boy, right? Probability of girls and boys are equally as likely. So it's pretty easy because if we want to do at least one boy, the complement is no boys. So that's 7 all girls, right? And they're equally likely. So you're going to have 7 dashes, 1/2 in each of the dash because it's a 50-50 chance of getting a girl. So basically 7 girls in a row is 1/2, 1/2, 1/2. So 1/2 7 times. And then it's going to be the complement's going to be 1 minus that. So 2 to the 7th is 2, 4, 8, 16, 34, 62, wait, so 30, darn it, 2, 4, 8, 16, 32, 64, ugh, 128. So that's 1 over 128. So when you subtract it, it should be 127 over 128. Okay, that easy. Can the couple be confident that they will have at least one boy? Well, yeah, because that is really close um, to 0. I'm sorry, to 1. Wow. Can you tell it's Sunday? Okay, find the probability of a couple having a baby boy when their 6th child is born, given that the first 5 children were all boys. Assume they're equally likely. So here they're trying to trip you up because remember, these are independent events. It doesn't matter what happened the first 5 times, the first 6 times, or the first 4,000 times. The probability of a couple having a baby boy um, for their 6th child is the same probability of them having a boy on their first child, their second child, or their 95th child. It's still going to be 1/2 because these things are purely independent, right? These are independent events. Every new kid is independent of the previous one. It's like rolling a die over and over again or flipping a coin over and over again. Those are all independent events. So is this result the same as the probability of getting all boys among 6 children? Is this result the same as the probability of getting all boys? No, because we're just asking for the probability of the 6th child, not the probability of 6 children, right? See the difference? The second event involves more possible outcomes. Yeah, I guess that's what they mean. Let's see. Yeah, that's kind of a poorly worded question, but you get what I'm saying. Um, this is just a 50-50 chance of what the 6th child will be versus what's the probability of getting all 6 boys. Well, see, in that case, you've got 6 dashes and you got to fill in all 6, right? Here we just have 1 dash, so it's obviously different. All right, we're already halfway done. The probability of at least one of them has a crash during the year. Well, remember, the probability of at least one is 1 minus the probability of no crashes, right? So How many do we have? Probably at least one of them from probably randomly selected crash, this much. 4 cars. Okay, so find the probability that at least one of them has a crash. So if we want to take this, it's 0.0483. So we know we have 0.0483 is the probability of a crash, right? This is number 6, I believe. And this is section 5, not 6. So the probability of at least 1 in 4, right, crashes is the same thing as 1 minus the probability of no crashes. So if this is our probability of a crash, then it's going to be 1 minus the probability of no crashes in 4. 1, 2, 3, 4. And each one of these is a probability of no crash. If that's the probability of a crash, no crash is 9, 5, 1, 7, right? It's basically just 1 minus this. And then you put that in all 9, 5, 1, 7, 9, 5, 1, 7, 9, 5, 1, 7. Multiply that all together and, do 1 minus that. And that's going to be your answer for that one. Okay, here we've got a data table. Assume one individual from the group is randomly selected. Find the probability of getting someone who tests negative given that he or she had a disease. Now, the book wants you to use formulas. And if you want to use formulas, be my guest. But I think the formulas are a waste of time. I think they overcomplicate things. I think it's a lot easier to just use the idea that given all the given condition does is it resets the question. Instead of looking at everybody, we're only looking at, sorry, I'm trying to get a new slide and it's not giving me a new slide. There we go. That when we have a given condition, all it does is it focuses us. Instead of looking at everybody here, right? So remember, the total of all individuals would be all 4 of these added together. You'd have to add all 4 of these together, and that'd be the grand total of everything that's involved in this sample space, right? So if we were going to select one individual at random, it could be one from amongst all of these, which is about, I don't know, 280, 290 or so people. If you add them all together, close to 300. Well, we're not going to grab one person at random from the whole group. We're going to grab one person at random, but from some small or subset, some subgroup based on the given, right? Find the probability of getting someone who tested negative given that he or she had the disease. So we know that the person we're grabbing comes from the group of people who had the disease. So instead of looking at everybody, we're looking at just these 146 people, right? So those are all the people who had the disease. So out of those 146 people, what's the probability that we pick someone at random and they tested negative? Well, 15 out of 146. That's the answer. It's that simple. Probably a similar question. Find the probability that the subject lied given a negative test result. And then they're going to ask a bunch of other side, ones. So let's copy this table and, go to work on these questions. All right. Okay, the first one they ask us for is probability that they lied given negative test. So if we're given a negative test, that means we're only looking at these 42 people, right? So good over total. Our total is now 42. Out of those 42, the good are the ones that did what we asked for in this case, so the ones that lied. And you see how we only had 9 that lied? So the answer would be 9 out of 42, which of course reduces to 3 over 14. And you could put that in, 3 over 14. Did I reduce that wrong? Nope, I just didn't read the instructions. They wanted it rounded to 3 decimals. So I had to change it to a decimal and then everything's good. Okay, so the second one they asked for is the probability of a negative test result given that the subject lied. Well, we still only have one dash because we're still just picking one individual, but now we know that that individual lied. So now we're looking at all of these people. These are all the people who lied. So that's our new total. We add those together, and now we have a total of 52. And out of those 52, how many good do we have, right? How many do we have that did what we asked for, which is had a negative test result, and that's 9. So we do 9 out of 52, and then convert that to a decimal because they want that one to a decimal to 3 places. And then, of course, they ask us, are these two things equal? And you go, of course not, they're not equal. You can tell just from the fractions, but you can also tell from the decimals. And it makes sense, right? Because they're asking two completely different questions. And if you look at the pictures, right, we have two completely different totals. On the first one, we're looking for everybody who had a negative test result, which was 42. On the second one, we're looking through everybody who lied, and that's 52. So the only time these things would ever give you the same is if these numbers were the same, right? If these were both 33 or both 43, then we would have got the same answer. But, that's a rare situation. Okay, on to the next question. They give us a table of stuff, right? So another one of these things. And they want us to find, again, pretty much the same exact question we just did before. I'm not going to waste time doing this one, guys. It's the exact same thing, right? Subject told the truth versus given a negative test result. So a negative test result means you're looking at the bottom row, which is 43 people. Out of those 43 people, how many told the truth, right? Did not lie? 34. 34 out of 43, make it 3 decimal places. Negative test result given they told the truth. Well, told the truth mean they did not lie, so we're now looking at these two together. So that's a total of 46. Out of those 46, how many had a negative test result? 34. 34 out of 46. Again, 3 decimal places. Compare the results, they're not going to be the same. All right, number 9. Commercial aircraft for flying instrument conditions are required to have 2 independent radios instead of 1. Assume that for a typical flight, the probability of a radio failure is pretty small. What is the probability that a particular flight will be safe with at least 1 working radio? So it's an at least 1 question, which remember is the same thing as 1 minus the complement. So in order for something to, not be safe, they would have to both radios would have to fail. So that's basically what they're asking. So they tell us here, this is question 9. We have the probability of a failed radio, right, is 0.0037. So the probability that at least one works, can't spell, is 1 minus the probability of none work, which is really 1 minus the probability of both fail, which is 1 minus, well, if they both fail, here's my 2 dashes, 0.0037, 0.0037. Multiply those, subtract it from 1, and that's going to be your answer. It's that simple, right? So it looks like so far all of our questions are at least ones and then some conditional probability. Okay, the last one we've got here, number 10. Testing for disease can be made more efficient by combining samples. If the samples from 5 people are combined and the mixture tests negative, then all 5 samples are negative. On the other hand, one positive sample will always test positive no matter how many negative samples it's mixed with. So if a sample comes back as positive, that means at least one of those 5 people has whatever you're testing for, right? Has the disease or whatever you're testing for. Now, assuming the probability of a single sample testing positive is 0.2, find the probability of a positive result for 5 samples combined into one mixture. Do you see how this is really just an at least one question? Because they're saying if I put 5 samples together, what's the probability that that big mega sample comes back with a positive result? Is basically just asking what's the probability that at least one of those 5 samples is positive, right? So we know it's going to be, the probability is going to be 1 minus the probability of all 5 of them being negative. And if they're a 0.2 chance of being positive, then they have a 0.8 of being negative. So it's going to be 1 minus 0.8 to the fifth, because that's going to be 5 samples of all 0.8. Okay, so that's 4.5, guys. Make sure you can go through it all. The bottom line is I want to make sure that you can do simple at least one questions, which means you have to know that it's the easiest way to do it is 1 minus the probability of none, right? And then just be careful with the wording because sometimes the English of the questions gets things a little confusing. And the only other concept you're supposed to be learning from here are simple conditional probability questions. If you want to use the formulas, be my guest, but it's a lot easier to still use the dash technique and realize that all that happens is the given condition just resets the problem, and instead of looking at everything, our total is now just that subgroup from the given condition, and then we look within that subgroup and count up how many good we have. So it's still good over total, it just gives us a new total and a new good. All right, hopefully I'll see you on Monday. If not, we'll be there on Wednesday to probably take our test. I'll keep you guys posted.